What's up, fellow polymaths? In this video of the Java Fundamentals tutorial, we'll be going over inheritance. Inheritance is also known as an is-a relationship. Inheritance means to pass down the variables and methods from a superclass to a subclass. The subclass is the class that inherits from the superclass. Inheritance is great when you want to reuse variables and methods that are in a different class, which reduces repeated code. The extends keyword is used for a subclass to inherit from the superclass. With the properties of the extends keyword, the subclass will be able to inherit all the properties of the superclass except for the private variables of the superclass. So we went over inheritance in a few tutorials, the use of the extends keywords, being able to inherit from, for example, the dog class inheriting from the animal class, or the bird class inheriting from the animal class. There's definitely more to inheritance, so let's keep going. So you're probably familiar with this by now. The syntax here is we have a class called the parent class, and then if you want a child class to inherit that parent class, then all we have to do is just extend the parent class. There are different types of inheritance in Java. There's single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance. Single inheritance is the simplest form of inheritance. Basically, it's just a subclass inheriting from the superclass. And we've seen this before, so all it is just a class Y extending the class X, which class X representing the parent class and class Y representing the child class. Multi-level inheritance is a class inheriting from another class, which that class inherits from a parent class. So you think of it as the grandparent, the parent, and then the child. Class Z in this case represents the child, class Y represents the parent, and class X represents the grandparent. So that's why it's called multi-level inheritance. Hierarchical inheritance is when multiple separate subclasses inherit from a superclass. And basically this is where we have many child classes inheriting from one or a few superclasses, as we saw in the previous tutorial using the dog and the bird classes to inherit from the animal class. That's an example of hierarchical inheritance. So we haven't really went over interfaces. Basically an example is where we can have multiple interfaces, and then we can have a class implementing those interfaces. So that class will be able to implement the features that are contained in those interfaces, and the class can implement as many interfaces as possible, although it's best practice to only implement what's necessary. Hybrid inheritance is a subclass inheriting from a superclass and implementing one or more interfaces. So basically we have an example where we have an interface, and then we have a class, a parent class, and then we have a child class extending that parent class and then implementing the interface. Just a quick note about inheritance. For subclass to inherit the capabilities of a superclass, the access modifier of the superclass can't be declared as final. So basically, if you want a child class to inherit from a superclass, the superclass cannot be marked as final. So we talked a bit about the super keyword in the past, in the previous tutorial. For invoking the superclass constructor, if a class is inheriting properties of another class, the subclass automatically acquires the default constructor of the superclass. But if you want to call a parameterized constructor of the superclass, you need to use a super keyword. So basically it's saying that if you want to use the constructor of the superclass rather than the child class, you can use the super keyword to do this. So as we mentioned before, is-a relationship is just a way of saying that the object is a type of that object. So when you think about this, you can think of, for example, if we have an animal object. So we know that with animals, there are subtypes of animals, such as mammals. All mammals are animals, but not all animals are mammals. So in this case, a mammal would inherit from an animal. So as we see here, reptiles are not mammals, but they are animals. So they would inherit from animals, but not mammals. But a dog is a mammal, and the mammal also inherits from the animal. So the dog inherits from the mammal as well as the animal. And you can think about it with other types as well, like vehicles. A car is a vehicle, a boat is a vehicle, a truck is a vehicle, and so on. Pretty much any real world representation you can think of has some sort of relationship. Just think about it for a minute or so, and you can think of all of the types of relationships that are possible and what they are derived from, and pretty much it involves some sort of inheritance. While is a relationship is based on the state, the has a relationship is mainly based on the usage. So this determines whether a class has a certain thing. The relationship helps to reduce the duplication of code and potential errors. So for our example with the has a relationship, we have three classes. So we have a vehicle class, a car class, and a speed class. And within the car class, it is extending the vehicle class, which the vehicle class represents the parent class. And then we also see that it's initializing a variable from the speed class. But we also see within the car class that it's declaring a variable within the speed class called speed. So what this shows is that the car has a speed. Remember, has a is based on usage, and is a is based on a state. By having a separate class for speed, we don't need to put the entire code that belongs to speed inside the car class, and that allows for being able to reuse the speed class in multiple applications. So in object-oriented programming, the users don't need to be concerned about which object is doing the real work. And to achieve this, the car class hides the implementation details from the users of the car class. So what happens is that the users would ask the car class to do a certain action, and the car class would either do the work by itself or ask another class to perform the action. So a lot of this combines polymorphism and inheritance together, as well as abstraction. So with inheritance, we have an instance of keyword that can be used to check if a class is a child of another class, either using the extends or implements keyword. But as you can tell, the instance of keyword works with both classes and interfaces. So I know I've been talking a bunch, and you're probably getting bored by now, so let's jump into the code and try some of this out. Alright, so we've worked with inheritance a bit in the past, but let's do a little bit more with inheritance. So we have an animal class, and right now it only has one method, but we want the person class to inherit that animal class because the person is an animal. Of course, I don't mean that in a negative way. So what we would do is hop over to the person class, and then we'll just extend animal. So we just keep our variables the same here. We'll also create a constructor just because it can be useful. Alright, so we created two constructors, one with empty parameters and empty value, and another with 3 parameters. So here in our talk method, we just say something simple like my name is getName and I am a human. So let's hop over to the main method and call this person class. So here in the main method, we're just going to create an object for the person class. We'll just call this person1. Alright, so in the main class, we created a person1 object and we set the name to Troy. So now we're going to call that talk method and we're going to see what happens. Alright, so here we have our result. The person says my name is Troy and I am a human. So we saw that in the person class we inherited from the animal class, and that animal class had that talk method which the person class overrided. So we can use the instance of keyword to confirm that the person class is of the animal class. All we have to do is just type out whether the object, in this case person1, is instance of animal. We also do the same with if it's an instance of a person. Alright, so now we're just going to run this again. Alright, so we have our result. So the last two output commands are both true. So we confirm that the person1 is an instance of the person class and the person1 is an instance of the animal class. So this is useful if you want to determine whether certain objects are derived from or inherited or are implemented from either classes or interfaces, respectively. Alright, here's our assignment for this topic. Number 1, what is the keyword that is used to inherit from a parent class? Number 2, true or false? A child class can inherit from multiple parent classes. If false, what is a round inheriting from multiple instances? Number 3, write code that will contain a parent class and a child class that inherits from the parent class. Output the results of the main method. Number 4, do the same as number 3, but this time have a child class that inherits from the grandparent class. So in this case, there will be 3 family of classes. Number 5, what is the keyword that can be used to check whether a class is a child of another class or interface? If this video was of any value to you, then please leave a like, comment, share, and subscribe. Thanks for watching, and I'll see you later.